Hey everyone, I'm David, aka Coma2000. Welcome back to my channel. I hope you have all seen my beginner's tutorial for VCV Rec 2. There we have tried to build a simple patch with only the basic modules, and we produced some stereo wind noise. And what I was thinking is that I will try this again, but this time a bit slower, explaining a bit more, because we have time. And breaking the fourth wall, I actually tried this earlier, this patch from scratch, and I made a crucial mistake. And I will explain to you this mistake first. What I did, and we'll do this again, I added the recorder module. So you right click or double tap and you find the recorder module. And then I patched this in. Let's see, where is the sound coming from? Well, we've seen this in the tutorial and we went through this in an hour approximately, that we just follow the cables. The input is coming from our keyboard, the computer keyboard, and these signals, which would, if they came from a MIDI keyboard, they would be MIDI signals, are transformed into CV values here, control voltage, minus to plus 10 volts. And then this volt per octave pitch output, which is at 0 volts now, is going to various places. It's going into this VCO, it's going into this VCO, and it's going into the wavetable VCO. Let's just go with the first cable. We go to the volt per octave input on the first VCO, and this one has its frequency modulated, but that doesn't matter for now. That's the input for the pitch information, and that's going to be transformed into sound. This is the sound generating module, the oscillator, and it outputs a sawtooth wave, which is going into the first channel on the mixer. And the other channels, if you look, they are coming from the second VCO and the third VCO and the noise module. And these are all mixed together in the mixer, and it's going out to a voltage controlled filter where the cutoff frequency is turned down, but it's being modulated by this ADSR envelope. But if we just follow the sound further, we see we are going in here, it says in. And where is it going out? Well, here, the outputs usually have a black background, so it's easier to spot. And the low-pass filter is going into our audio module, which is now going nowhere because we have no device selected. But if we select a device, built-in output, then this is going to be output through our speakers or headphone port. And now we would have to connect this low-pass filter, the final output, not only to the audio module, but also to our recorder. Back to the mistake that I made was that I pressed record here. I will show you. And if you press, you have to select a file. So we already have one recording here in the default recordings folder. So let's call this untitled 2. And now we save and we record. And what I did is I later decided to make the stereo sound instead of mono, so I patched in the right input as well. However, because we already started recording, the file was created as a mono file, so it will not turn into stereo, so one of the channels was not recorded. It's a very obvious mistake, but now I know better and hope you won't do this mistake. So let's just start over. Let's stop this recording and start with a new blank slate. We go to File, and this is going to be, again, very beginner friendly, so I will be explaining hopefully every step that I'm doing. If something is not clear, feel free to drop me a comment down below. So we click New, and then we don't want to save, so we click OK, and then we have the same basic patch back again. Now what we are going to do is actually delete most of the stuff here, maybe everything. So you can select all the modules that you want to delete in VCV2 with the mouse, just like this. And then you hit backspace or you right click and select delete. Let's do it like this. And here you just click on it, backspace. You click on it, backspace. Click on it, and there it goes. Disappeared. Now we have the audio module, and what we need is a recorder, so I can record the sound for you And you can also hear it, or if we want to record our patch for ourselves or others, this is the module that we use. There are other recorders. For example, you can do polyphonic recording. Maybe I will do a tutorial about that. That's a lot of fun, because there you have all the channels separately and you can work on it. However, it also creates more work for you, so often it's just easier to record everything here and we are finished. So we have the audio module, we have the recorder. We need a sound source. Let's start from the beginning. This is the end. Let's use the VCO from VCV. There are a lot of other VCOs, so you can select many more if you install all these modules. But let's stick to the basic modules. And then we want stereo sound. So let me think ahead a little bit. We need a left channel and a right channel. So let's add 2 mixers. And we select now only the VCV branded modules. So we filter this out, and now we have this mixer and this mixer. So let's pick this one and let's duplicate it. So right click, duplicate. So now we have 2. And we are going to feed the mix output into the left channel and the other mix output in the right channel on the audio module, and we'll do the same with the recorder. It's not a problem that we already have something patched in here, because in VCV you can just connect multiple cables to one output, or multiple cables can go from one output into various inputs. So what you do is you press Control on a Windows PC or Command on a Mac, and then click, and then you have another cable. And that will go into the left channel on the recorder, and from the other mixer we will go into the right channel. And now we just have to feed sound into these mixers. So we have to add something in between here. We have to go from the VCO, the sound source, up till here, because from here we have already patched in the cables to both the audio module and the recorder. What we want to do is we want to filter this noise. Well, actually, I wanted to do noise and I added a VCO. So let's add a noise module as well. Maybe we'll use the VCO for something now that we already have it. But let's start with the noise. So you have the noise module. Let's try white noise. Let's feed it into channel 1 here. But first, you can already see the levels are too high, so we turn this down, or you can also turn it down on the mixer here. What we are actually going to do is we're going to filter this noise first. So we are going to add a filter. It's called the VCF, a voltage controlled filter. We might control it with control voltage, or we'll do it manually, we'll see. So let's go from this output with the black background into the input. It's very clear, it says in. And then you go from the low pass filter, which means that we'll only get frequencies below this line. So here, wherever you set the knob, only the low frequencies, because white noise is very high pitched. So I personally don't like the sound of pure white noise. How about you? Which type of noise do you like? As you noticed, I really like noise. So you have white, pink, brown, and all the others. And we go from the low pass filter into, where are we going? We have multiple inputs. We have a CV input, but that's for the mix level. We have CV control, but it's for the levels here. But for the audio, because it's audio signal, we have to go into the input here, in 1. So we go from here to here. And now, to get stereo sound, what we need is we have to shift the time of this. We have to delay the audio signal a little bit. So for that, we need a delay module. So we add this delay, and we'll feed the low-pass filter, the same output, into the delay first, and then its output, let's pick the mix output, into this mixer, but not the CV input, rather the in 1 input. And now what is happening is that we have the same sound on the left and right, but they are, well, let's hear. Why am I trying to explain what it sounds like when we can use our ears? I have to set the levels here. Let's set this to 0. I double-clicked here, and that means if you double-click on a control, on a slider or a knob, then it goes back to the original default setting, which is at 0. You can, of course, reset the whole module if you want by right-clicking and then not on a knob, rather on an empty space, and you click Initialize. Or you can use keyboard shortcuts as well. And now we're back there again. Now everything is reset here too. Yeah, the levels are lower now because we are actually filtering out quite a lot of the noise. We're going in here, there is here, we are going here, we are going here, we are here. Aha! I was wondering why I don't hear anything, but now you know, because I have no device selected here, and you don't hear anything either because I haven't started the recording. Let me start the recording and you will hear it first. So we call this wind and save. And now I select an audio device. I use the built-in output. Yes, and now I can hear it. Yes, it's some rumble. Sounds like wind. Let's see. Let's hear. If I turn down the delay time here, sorry about that, then we basically get a mono signal. So the left and the right ears will sound the same. Like, now one is quieter than the other, of course. However, if I increase the delay time, I try to do it slower than before. If you press Command or Control, you can do fine adjustments, of course, but I don't want to go that slowly. Rather, I want to turn it up so we can hear the difference. That was the delay effect. And now I will move the cutoff frequency. So that's the kind of effect we want to achieve, but I don't want to constantly turn this knob up and down. So we'll try to automate this somehow, and we can do that by patching in here to the frequency input. Like, this is the cutoff frequency. We are at 320 Hertz, so basically anything above that you can't hear. Well, let's add a scope and let's see it. And now we patch in the output, the low-pass filter output, to the scope. And we can also patch in the... Well, no, what we do is we'll patch in the output after the mixers. So then we'll also have the delay effect on the other one. So now we go from the mixer to the second input on the scope. We'll increase the gain a little bit. Slow down the time. Or maybe make it faster. Now you see the audio coming in here in a visual form. You see that the two colors are not moving together, so we are in stereo, and you can also hear it. So where was I? I wanted to show you the stereo effect. And what other mistakes did I make here? Well, for one, we have the mix input patched in and not the wet input, so basically it's mixing together the original input with the delayed signal. I want only the delayed signal in the right ear, let's say, so then we turn the mix knob up to 100%. And now we get exactly the same output as if we were patching into the wet output, because this is now 100% wet. Let's try to turn the filter, and then we'll do the modulation. Now you can hear it really well. I like it, but you can play around with this for a very long time, so please download the patch from patch storage, play around with it, turn the knobs, and see what you get out of it, because I can play around with these knobs for a very long time. But back to the lecture at hand, let's add that LFO that we are going to use for modulation, because what we want basically is for this knob, as I explained in the tutorial, to go up and down smoothly, or however you want to turn it, and that's what you are setting with this modulation. And here we have various outputs, so you can move this knob up and down smoothly. Then you would use a sine wave, or if you use a sawtooth wave, let's visualize that too. Let's get another scope, because we need another input. And now let's see this LFO. So we have the sine wave here. So this is very fast, so let's turn down the frequency. And now if we go here, then we're going up and down, up and down. So what would happen here is we would open the filter and then close it. So we would open and close, and then open and close, but it's still too fast. And then this is the starting point, of course, from where you start opening it, and how much you can adjust with this knob above the cutoff frequency VCV input. So let's patch this in. So press Command. I'm doing it like this now. I was always going the other way around. I was always going from the input to the output. This was just easier. I didn't have to press Command, but I realized that it's clearer when I'm explaining that we are going from the output to the input. And now it's doing nothing, of course, because even though this is moving, this is outputting the sine wave, but we have this knob turned to 0% modulation. So if we put this to 10%, that means that we would go from 270, you add 27 to that, so to 297 approximately. So we would go from here to, not much actually, 10% is not much. So this is 10%. Well, in sound you can actually hear it very clearly. I still want to go a bit slower than this. And then you can do all sorts of crazy stuff. You can modulate the frequency of this LFO, for example, with this frequency modulation. And then it's not just the sine wave going out, but its frequency is being changed. So, well, maybe we can see this on the scope. If I add another LFO, I really like to do this trick because it introduces even more, it's not a trick, even more movement into the sound, because now we are just opening the filter and closing the filter always with the same regularity. So let's say it takes it 5 seconds to open, 5 seconds to close, and that's a bit boring and very repetitive, so you get used to it. Sometimes repetitiveness is good. For example, in some music, it's really nice, it gets you into the flow, but here I want a bit more controlled randomness. So I patch in this here. So we are now modulating the frequency of the LFO itself. Let me turn down the volume, it's a bit loud. Where should I turn it down? Well, we have to now control the two channels separately. I can turn down my level here, but I can't turn down your level, so... Well, I can do that, but then I can't hear it, so I don't want to change the recording level here. I rather want to change the output level, so let's just go first on the left and first on the right. And now I have this patched in here, this out there. I want to see what's happening. So nothing is happening, of course, because we have this frequency modulation CV control at 0. But watch now, here on the scope, what will happen. And also listen maybe. Now it's going faster down and up, and now it's going slower again. Like, we could visualize just this one LFO, of course. Wow, it matches the color of the cable? Wow. I never noticed that. Very cool. Let's go with yellow. I'm just changing the display time, so now you can see what these two LFOs are doing. The first one, the yellow one here, is just going up and down with the same period, but then the other one is being, its frequency is being modulated by the first one. Well, I explained it already, and now we're just visualizing it and we're listening to it. Maybe it's confusing to see the first one because we don't really care about that. We only care about this because that's what's opening our filter and closing our filter. And now I hear it's way too fast at its fastest. So we have to turn down the modulation here quite a bit. Turn down this here to make the changes a bit smoother. And let's take our time and listen. In the meantime, we can clean up our patch a little bit. So that's that. We are at the bottom here. So now if I go down, we can approximately hear where it will go at its well, it's at its quietest, but it's also all the low frequencies. Now we're going up, so we are at the maximum, and now we can play around. Okay, so this is approximately the sound I want to achieve. So I'm quite happy with this. You can play around with it more if you want. Twist the knobs, try some other sounds, change the delay, change the cutoff frequency. I think the tone is doing nothing here. because it's just noise. Oh yeah, it's doing something. Play around with that. I don't know about resonance here, but you can try that, you know, you can experiment, and that's the cool thing. So, have a good one. But I'm not finished yet, because we have this VCO here, and if I already added in the VCO, let's try to do something with it. We have the oscillator. Let's feed this through a filter. Let's make a drone sound, something simple. I don't want to overcomplicate this video. Let's now go with a different type of wave, and we can actually listen to that. Let's patch in the low-pass filter into both of our mixers. And let's turn it down, because we never know how it will sound. How loud it will be, I mean. Some mixers have a dim knob, dim button here, so you can just click, and you have mute buttons, but this is very basic, so. But it's good enough for us now. I will soon enough switch to another mixer. And I really like the MindMel mixers. But for now, let's stay with this one. And the main reason, because I want stereo output. It's just too much hassle to do this all the time, but already in the next tutorial, we are going to get away from only the basic modules. So I want to patch in the, let's say, the sawtooth wave. And now you can hear your oscillator, and it's well, not a drone, because the frequency is way too high, so we have to go down a few octaves here, and we could actually this time use the oct module. I rarely use this. I just set the frequencies on the oscillators themselves. Some of them have this octave control already built in, but you know, you can build almost everything from only these basic modules. It just takes you a bit more effort, because many modules have the same functionality, just a lot of functions already built in. Of course, some others which generate sound, they have some unique sound, and but for now, I actually really like the sound of this VCO, so let's hear it at a lower frequency. Let's patch in the volt per octave input here, and then this goes through this module, right? Our little white box, and inside this little box it does something which we didn't program, but we could, because what it does, it's very simple. It just subtracts 1 from whatever input is going in here. So it's just a -1 operation, because these are all voltages virtually, so it's just numbers. Like that V that you see at the end, it's not real electricity, obviously. So it's just numbers that you see there, and whatever you see on now displayed, you get -1 down here if you set the octave knob 1 octave down. So whatever frequency we have, we go down by 1 volt, because it's 1 volt per octave here in VCV rec and in Eurorec. So enough talking. Let's go down by an octave. What am I doing? Because here it's going down. Here it's not going down. I see, because you need the volt per octave input. It's just pitch information that is being transposed here, not actual sound. You can't shift it down by an octave. That's wow, what a rookie mistake I made. But maybe it's I shouldn't have told you, but it's good for understanding and revision that you see that some of the cables are carrying, they are all carrying virtual voltages, but some of them are control voltage to control various parameters here, and you know, they can go also very fast up and down, but it's going to be a big mess. So you can control the CVs with audio signals as well if you want. But if you look at the scopes, you can actually see the difference between the two, especially if I set the time to the same time here. Then you see that there's a huge difference in what is happening. So, but they are both the same conceptually, current, electric current in a virtual form here. So I'm over-explaining this, but whatever is happening in here, you have to feed in control voltage and not sound. And this is sound. You see, this is this. So that's why I'm always doing it on the VCO. So let's forget about this oct module, and then patch in the sawtooth wave into the input here. And now we are going down by an octave, and if you can divide by 2 quickly, then we go from 261 to 130. Let's just go with 130. Let me turn down the mixer here so we can hear the other channel. Here it is. It's just the frequency is high, and the filter is cutting off all these high frequencies. So here we hear nothing. We don't hear anything anymore at 50 Hertz. So let's turn this down. Well, I wanted to go to 130, I don't know what happened. And then let's go to 65. And then let's go to, well, let me turn this down a little bit. Let's go to 32. 32.5. Okay, let's go back to 65. So these are the frequencies. This is the pitch. We are going up and down by an octave each time. However, the sound is filtered by this filter, so it cuts off the high frequencies. So if you want a bass sound, you want to turn this down and also turn the filter down until, and you play around with these two knobs. Of course, if you are making a song, you have to stay in key. So you can't just randomly turn this wherever, because now we are at who knows what note, below C, that's for sure. And this is the effect when you're opening the filter, right? Now this with a delay is magic, but we won't do that, because we only want the drone sound now here. Actually, you know what, let's do it. Let's add the LFO. I really wanted to keep this simple, but I can't resist. So if you want to turn this filter up and down, then, well, let's go with the triangle wave. You can do it automatically. Now you want some resonance, of course. The drive knob only increases the volume, so it's a gain knob basically. Now let's do the same trick as with the first one, that we modulate the frequency of the LFO itself. Let's visualize this triangle wave first. Well, let's go with a different color. Well, I'm so happy about this that I found out about the colors. Red. So we want to modulate this. Let's add another LFO. And let's choose. What does a sawtooth wave look like? Let's see. It goes up and then suddenly down. Yes. So it goes up and then down. So you slowly turn this up and then puff back. We don't want that. So we are going with the triangle wave, let's say, or the sine wave for the frequency modulation. But this is way too fast. You can see it in the blinking as well. And now you set the knobs. This is from where. Let's see what is going on. Yes, the VCF is here. It's easier when you put it from left to right, of course. We start with the VCO. We were okay. Because this is just modulation, right? Oh, I didn't like that sound. It's the drive. I mean not the drive, the drive here, I mean. Okay, now we need a bit more order here in this system because I'm already losing track of what is going where. So let's look at this quickly again before we finish. So we have two sound sources. We have the noise and we have the VCO. The VCO is going into the VCF, the filter. The cutoff frequency of that filter is being modulated by this LFO. But this LFO's frequency is being modulated by another LFO here. So this is for the VCO. And the VCO is going in through the VCF into channel 2 on both mixers, so that's fine. Now we have the other sound source, the noise, which is going into this VCF, and then from the low-pass filter into channel 1 on both mixers, and this VCF is being modulated by this LFO, so let's put this up here. And now we are not so confused anymore. We just had so many LFOs. We have 4 LFOs now. I love to use a lot of LFOs for modulation, but you can also use some other modules, mutable instruments, tides, for example. Maybe we'll look at that someday, can generate some more complex up and down movement, different waves. And now basically we want to listen to the sound, remember what we did, and then know where to change what. Now it's all clear. This is the noise, this is on channel 1, and this is the sort of drone sound. And well, it still goes a bit too fast for me, so I want to turn down the LFO a little bit. We can open it further. I mean, I keep messing this up, but that's when you have so many modules. You have to open it here. Let's turn up the noise a little bit. Now we just set the levels on our mix, what we like the most. Let's try to set these two to approximately the same. So let's say this to -8. Like if you right click on a slider or knob or an input or like control surface, then you can enter the exact value that you want. So let's go to -8. I want this bass drone to be very subtle, but you can of course turn it up if you want. But I want the wind noise to, sort of wind noise, this noise that we are producing and filtering, to dominate. But then again, as you turn these knobs, these levels wherever you want, so download the patch, play around with it, let me know what you think. And now let's add a blank module, or even a notes module, and then a blank module. You can make this smaller, like this, and then I will say enjoy, and now I'm saying goodbye. I hope you enjoyed this video. See you in the next one. Peace. I'm still here. I'm still listening to this sound. It's not too bad, actually, for such a quick and simple build. You can fine-tune it, of course. But I will actually say goodbye now. Maybe I'll record this longer and play around with it and then make a recording and upload that too. But feel free to do the same. Get the patch, play around, upload it, do your thing. See you in the next one. Bye.